We're going to start off with Dr. Scott Goetz is going to give us a presentation on the Arctic-Boreal vulnerability experiment. And Scott Goetz is a professor at Northern Arizona University in the School of Informatics, Computing, and Cyber Systems. And he's also the science team lead for the NASA ABoVE campaign. So please take it away, Scott.
Okay, thanks, Liz. Let me screen share here. Hi, folks. I recognize some of the names and glad you could join. I think this is the fourth time I've done an update on ABoVE, NASA's Arctic-Boreal vulnerability experiment for IARPIC over the last, I don't know, 6-7 years, I guess. A number of you are already familiar with ABoVE, so I won't go into the background at all, other than to say it's a 10-year campaign being conducted in 3 phases, and the science lead and Chip Miller, JPL, is the deputy lead, and there's the folks at the Carbon Cycle and Ecosystems Office, including Liz Hoy, who you just heard from, and who helped put this presentation together. And I'd also really like to acknowledge the greater ABoVE science team, of which I know several of you online are members, for all the work you've put into making ABoVE successful, which I believe it is. Advance. Okay. Yeah, so again, I don't want to go a lot into background material. I think probably many of you are familiar with it, but ABoVE is one of these coordinated interdisciplinary NASA field campaigns that take place periodically. It's a big investment on NASA's part. And as I said, they're scoped at like on a decadal timescale. So there's quite a significant investment, not just of resources, but of time and dedicated effort and proposal reviews and so on and so forth. So it's a multi-scale activity, from very local field measurements all the way up to, since it's NASA, of course, using satellite imagery and using products from satellite imagery to inform models. So as I said, we're in year 7. We just started phase 3 less than a year ago, I guess 6 months ago or so. And the items underlined in red here or outlined are really where we are nominally headed or already in phase 3, the sort of final phase of ABoVE. And so that includes making an attempt to get at the societal drivers and finish a lot of data product development, especially on the ecosystem services side of things, integrate models, do cross-disciplinary synthesis activities. And that last item, I think, we started that early, and it's been actually quite successful. We've had quite a few synthesis activities, and it's something that we've tried to emphasize very early on. So that's gone well. Yeah, so it's a big effort. There are about over 500 peer-reviewed publications that have come out of ABoVE thus far, mostly from NASA-funded projects, but we also have affiliated projects. 118 of those, or 33 of those who've produced like 118 publications. So that's what this slide is showing. Some of them have been in high-profile journals like Science and Nature and PNAS and so on. There are over 1,000 science team members at this point, and almost an equal number of people who follow along and keep up to speed on what's happening with ABoVE. And as I always say when I present, the peer-reviewed publications are one important aspect of it, but the data publications and the data archiving is equally important, because data from these large interdisciplinary efforts gets mined for a very long time, and inform graduate student PhDs and so on going forward will certainly be happening even after ABoVE ends. So the data sets are well used and accessed, and hope you can take advantage of them if you're not already. Part of ABoVE was airborne campaigns, and these are a pretty significant investment. They're expensive, flying NASA jets around, and it's we pretty sure that ABoVE has made the biggest investment yet of any of these interdisciplinary field campaigns that NASA does, with a whole lot of different instruments over quite a large area. The image here is just showing an example of one instrument in 1 year, a LiDAR instrument in 2017, but we've also flown synthetic aperture radar and hyperspectrometry and atmospheric trace gas concentrations and so on. And we continue to do that. And we plan to do more in the future. In fact, Avarice is flying today as part of SNOX. I think it's flying today. They're trying to fly today, and they did fly yesterday, I believe. And part of what makes ABoVE a success, Liz put this slide together actually, is just the diversity of partners. So a lot of the IARPIC organizations, as well as a lot of universities, NEON and other programs across the US. And the same is true on the Canadian side of things, Polar Canada, Environment and Climate Change Canada, Natural Resources Canada, and so on. So there's plus universities and co-funded projects supported by these various agency efforts that we coordinate and partner with as much as possible as part of ABoVE. So in that sense, it is quite an international effort. We do have European partners as well. Fewer, but we do have some. Okay, so just a quick overview of some of the outcomes thus far, and you can learn a lot more just by following that link or visiting the ABoVE website. But the Hydrology and Permafrost Working Group has made a lot of progress over the last 6 years or so, phase 1 and 2. I don't think I want to read through these, but just to give you some idea of some of the activities, really getting a much better handle on carbon emissions, particularly outside the growing season or the shoulder seasons, which is quite important because they're a significant component, and we didn't have that very well characterized coming into ABoVE. So long running towers through the winter season is challenging, but it's really important to do. We've also got a lot better handle on methane emissions across the domain. I'll show you an animation of that. I think we have that in here. And then also remote sensing advances in terms of using like synthetic aperture radar, multi-frequency SAR to get at different aspects of permafrost systems. This is one example Kevin Schaefer put together using a combination of L and P band SAR, looking at soil moisture and also active layer thickness. It's really nice for us to be able to get at active layer thickness to the extent possible. It's really challenging though, but P-band SAR is like a 60 centimeter wavelength that penetrates deeply into the ground. And using that combined with L-band SAR, we're able to get at some estimates of active layer thickness. The problem with SAR is as soon as it hits liquid water, it's extinguished. So we can only go so deep in terms of getting an active layer thickness, but it's really significant progress. Carbon Dynamics Working Group has likewise made a lot of progress, all sorts of improvements in terms of constraining the carbon cycle, refining carbon balance estimates, not just across the ABoVE domain actually, but there's a Pan-Arctic paper that's come out not too long ago, really getting a better handle on the Pan-Arctic, Pan-Boreal carbon balance, including fire disturbance. We're getting a much better handle, we think, on the changing CO2 amplitude cycle, and again, methane emissions. This is a nice graphic that's getting at what I just mentioned in terms of Pan-Arctic, Pan-Boreal carbon balance, a paper led by Jenny Watts and a couple of others listed there, one that's still in preparation. And on balance, the Pan-Arctic Boreal region is still a net sink, But with all the recent fire activity, particularly in Northern Eurasia, but not only Northern Eurasia, it's that could easily flip to a source. And in fact, it already appears to have done so, at least in a recent year or two with the big fires a couple years ago. Here's a nice, I did have an animation of methane. This is a graphic that was put together, or an animation put together by the NASA visualization folks. So this is not just Arctic-Boreal, but the whole globe. Let's see if I can get it to run again. Well, I should be able to, but there it goes. So you can see it goes from like 2015, 2016 up to 2021, and varies quite a lot seasonally. And where it's ending here at the end of the growing season is where we see a lot of the methane emissions around, including in Alaska, central Canada, around Hudson's Bay lowlands, and central Siberia. Okay, the vegetation mapping group has also made a whole lot of progress. Again, I won't get into it. A lot of the changes, of course, in this region are dominated by fire disturbance, and we've done a lot of characterization of fire disturbance. And we've also improved models so that we're much better able to estimate near future changes in vegetation, and also its feedbacks to the atmosphere in terms of albedo, radiative forcings, and also advances in remote sensing using hyperspectral and solar-induced fluorescence. And kudos, I have to acknowledge the people who've contributed these slides, which are these sort of synopsis slides are from the most recent ABoVE science team meeting, which was held in January in San Diego. So the working group leads put a number of these together. Here's a nice animation that Laura Duncanson and Paul Montesano and crew have done using ISAT-2 LiDAR data combined with a whole lot of other data sources to estimate the amount of carbon in above ground biomass across the entire boreal domain. So this is a pretty exciting advance, and I think they're wrapping up the paper on this to be published soon, hopefully, and the data sets will be made available if they aren't already available online. So that's kind of a nice new result. And then this is a nice graphic. There's a wildlife and snowscapes working group, and this is kind of a cool animation of caribou migrations in the North American domain for a couple different years, 2013 and 2014. And you can see the various herds, the Western Arctic herd, the porcupine herd, Bathurst as we go left to right, and how they migrate in these different years. This is, of course, all finely tuned through evolutionary history. I'll play it again. But what's really neat to see, you can see the greening coming in, and you'll notice that the caribou actually start moving before the greening. It's easier for them to travel over snow, so they can move quite quickly up to the calving grounds on the coast. And then as it goes through the year, all the way into September, they circle back and start migrating southward again for the most part. So this is really neat results from collared caribou herds. Oops, sorry, I didn't mean to play it again. Okay, and carbon, I already mentioned there's lots of advances in terms of the carbon balance, methane emissions, but also there's a component of ABoVE that's focused on the terrestrial aquatic system. So there's a number of results here from that that I won't get into too much, but it's a combination of in situ observations combined with airborne data as well as modeling. And some of this work was facilitated by European aircraft joining the ABoVE campaigns. Yeah, and I mentioned wildfire disturbance. Of course, that's a huge part of the system. You're all familiar with that. I think we'll probably hear more about that from Randi next, from Randi Jandt. So there's a lot of work going on as part of the fire component of ABoVE, which really cuts across all the working groups and pretty much all aspects of the system. The graphic on the left here is just showing sort of, again, there's some of the airborne acquisitions that were acquired in different parts of the domain and the extent of fire disturbance in different colors. Yeah, and in phase 3, we also have a wildlife component. Well, we have in earlier phases as well, but as I showed you with the caribou, but that continues in phase 3. We've got some new, really quite interesting work on how beaver have migrated onto the north slope of Alaska, a project led by Ken Tape, and how they're altering hydrology, which in turn impacts permafrost in the system, and also work on migratory birds and wetlands. And that work is helped a lot by synthetic aperture radar as well. Here's a little bit more on some of the changes that are taking place in hydrology as a result of the beaver movement into higher latitudes. They've sort of done an end run around the western end of the Brooks Range and are migrating extremely rapidly and transforming a lot of the landscape, as you can see here, like on the right side from 1980 to 2019, just how the dams in the system have flooded and backed up these rivers, and that in turn influences the permafrost beneath them. And that in turn has implications for carbon and methane emissions. Other phase 3 activities are looking at bioclimatic gradients. This is J.J. Frost's work, led by his team, and also importantly incorporating indigenous knowledge and observations from elders in work, interdisciplinary work, and attempting to disentangle some of the complexity of the systems and the various components to predict what's likely to happen in the future. So that's pretty exciting. And then I think this is my last slide. I tried to go quickly. Hopefully I'm not too over time, but we do have a couple of special issues. One is part of environmental research letters that's been ongoing really from the beginning of ABoVE. There's already 80 papers in that compilation and quite a few more in the queue. So I'm sure we'll be well over 100 by the time phase 3 is finished. And we also have a brand new special issue that's focused on permafrost systems, but also with a request or a special emphasis on, again, incorporating indigenous and local knowledge into helping us understand what's happening in these permafrost systems and how we might better model it going forward. So that's an environmental research ecology. So yeah, that's it for me, and happy to take questions if we have time.
Thanks so much, Scott. We do have a little time for a few questions now, and then we can have a broader discussion at the end. But if you have a couple questions just for Scott right now, you can put them in the chat, or you can unmute yourself and go ahead and ask him. We'll let Randi, you're up next, so start getting yourself ready too.
I'm happy to take questions from anybody by email too, if they like.
I appreciate you doing the presentation, and one of the reasons we wanted to have it today is to hear about some of the highlights and some of the kind of what's new coming out of ABoVE, so that as a team, our team can think about where should we consider focusing our efforts. And so I think I'm not seeing anything in the chat right now, so we can all be thinking about that as we hear from Randi and Alison and as we prepare for our discussion at the end. So thanks, Scott.
Sure.
All right, thanks, Randi. So next up we have Randi Jandt and Alison York from the Alaska Fire Science Consortium. And Randi is a fire ecologist with the consortium and has over 30 years field experience in Alaska as a fire ecologist. And Alison is the coordinator for the consortium, and she has been working with scientists and managers to understand and address the impacts of environmental change since 1997. So thank you both for joining us, and I'm not sure how you have decided to divide it up, but we can't wait to hear from you. Thanks.
Awesome. Thanks, Liz. I'm Alison. I'm gonna start because I'm gonna talk a little bit about the sort of the bureaucracy behind the program. I'm the bureaucrat on the team, and Randi is the real fire scientist. So I just want to, because the program that supports us is a little unusual, and this is a broad audience, I just want to take a few minutes to explain how we're supported and how we work, because it is, as I say, kind of an unusual model in the science research world. So we're the Alaska Fire Science Consortium, and our mission is better collaboration between fire science and fire management in Alaska. And we're supported by the Joint Fire Science Program, which is a funding agency at the federal level that receives funds from both the Department of Interior and the U.S. Forest Service, the two major entities that are involved in wildland fire management. JFSP was started in 1998 by a congressional mandate to address research issues that were not being addressed by the larger research enterprise in the US at that time. Randi, can I have the next slide, please? And one of the things that I think is very cool about the program generally is that it does a lot of evaluation work to see whether the research is getting to the end users that actually need it. And that evaluation revealed shortly after the program was started that without really sustained effort, the research results that the program was funding were not actually getting into the hands of practitioners who could use them. And in response to that revelation, the Joint Fire Science Program established a network of 15 units across the country that called the Fire Science Exchange Network. And that's shown here. These units are tasked to work directly with the management community in each region to understand their science needs and deliver the most relevant science to support their decisions, and also to work with the research community and help develop research that will meet those needs. And then Randi, can I have the next slide, please? And there are a couple of aspects to this that I just want to highlight because, as I said earlier, this is an unusual program. This funding agency is dedicating at least 25% of their overall budget to these regional information hubs, which are, you could also think of as boundary spanners between the research and management community. That funding has been sustained since 2009. And that's a really important feature, that these entities are established in their communities and that the end users can rely on their continued presence. That's not like a grant funded thing where, okay, they're available for 3 years and then they disappear. Another thing is that the mandate of the Exchange Network is to deliver all relevant science that the end users might need, not just projects that have been funded by the Joint Fire Science Program. That's particularly important, of course, in wildland fire, where the science that supports management decisions comes from all kinds of entities, NOAA, USGS, many other entities beyond JFSP. Then, and I wanted to, especially for this audience, highlight that this is not just a sort of feel good, we think this program is effective, but that there's been a series of peer-reviewed papers looking at different aspects of how this program operates that have shown that, in fact, it is meeting its targets of the improving collaboration between management and research. In several different aspects, uptake and adoption of new science, helping managers adapt to climate change, and involving managers in co-production processes. I'm going to be putting some links to those studies and some other links about Alaska Fire Science Consortium and the Joint Fire Science Program in the chat after I turn it over to Randi, who is going to give us the rest of the presentation. Thanks for the opportunity, and take it away, Randi. She's going to give us her perspective on this problem. Thanks, Randi.
Well, thanks, Alison. Yeah, well, so that sort of begs the question is, why do we need boundary spanners and boundary spanning organizations? And it does seem that the arenas where fire science research occurs and where it gets used and applied, they really are different worlds. So from a manager's point of view, science research seems like Disneyland versus, the day-to-day stuff that they do is like the funny farm. And, on the other hand, from a researcher's point of view, an academic point of view, it's like having your finger in an electrical outlet. You have to fight for survival in the jungle of grants and publish or perish, and they perceive these managers having this placid, reliable work-life balance. So they really are different worlds. And I note that some folks on this call definitely have their foot in both worlds. So they'll probably have some good perspective on this. But management agencies are driven by issues, and often these are shorter-term issues. Whereas in the world of academia, big questions and long-term perspectives is often what drives these research questions. Scott's presentation was a great overview on how wonderful, they can do with some of these big, broad, pan-Arctic and global questions. So this slide is about really the benefits for academics to work with managers. The agency's experience provides this anchor to reality and to practical issues. How do you apply science to practical problems? And the other thing is that these agency folks have a lot of street cred, and they have this strong connection to the stakeholder public. So science guidance is needed for all of these things. On a more small scale, research and technology can help fire managers in particular with the nuts and bolts things like better prediction tools, fire season predictions, lightning predictions, better fire detection, fire response with everything from faster planes and drones and technology to improve lightning detection grids, ways to harden the power grid. And a lot of these items you will see on this list apply to better planning, better fire management plans that take our latest understandings of ecology into account, and better smoke models, and of course, public education, where agencies play a strong role again. So, for example, I just have a few examples now I wanted to share with you of things that we're really excited about working on, nice co-production projects in our region. And a current hot issue in management world right now is fuel treatments. There's a strong public and private push for this idea as mitigation for what's happening with fire and climate change. However, solid data on the effectiveness and ecological outcomes of these treatments is meager at best. Anecdotally, we think these things can be useful. And here's these photos here are an example of a experimental thinning treatment in black spruce in interior Alaska, where note that the fire behavior changed pretty dramatically between the control on the left and the treatment, where it was thinned on the right, especially with regard to fire intensity. So we think there's some value in these things, but there's a lot we need to learn. So management agencies are very eager for the help of scientists who will help them with this issue. And here's an example of one project, Melissa Boyd and et al. At the Northern Arizona University MAC lab showed that the treatments can indeed promote low flammability and deciduous-dominated successional trajectories, which kind of go together. However, she also showed that shear blading, which is where they go in where the ground is still frozen in the spring, usually with a bulldozer, and push off all the canopy, the tree canopy. So it's intended to not do as much surface disturbance, but remove the canopy. It's a clearing technique. This technique has strong effects on not only understory composition, but also permafrost degradation. And these effects persist for at least 2 decades after disturbance. This is important to know when you're planning these projects, especially around infrastructure. So another research group that's developing out of Michelle Mack's lab is expanding this work under a Navigating the New Arctic grant and studying several field treatment sites around Alaska, from Eagle Village in the east to the Kenai Peninsula and also around Whitehorse, Canada. And they are working closely with managers. Both management agencies and field specialists are involved in this, and they have assistance from the agency and Alaska Fire Science Consortium fire analysts to help model the fire behavior modeling trade-offs from the treatments. In fact, on this publication, two of the co-authors are agency fire ecologists. These are the folks who are guiding the interagency community on the design and monitoring of these field treatments. This kind of research is adopted as soon as it's available. We're actually waiting for it. So again, where should we put these field treatments? Jen Schmidt, who hails from the engineering school at UAA, is working hand in glove with boroughs, fire departments, and other government agencies to scientifically examine wildfire exposure and risk in the WUI. And this type of exposure mapping can be done to landscape scale, like shown here, and right down to the neighborhood scale. One of the surprising findings coming out of her study, which used a destructive 2019 fire, caused a lot of damage to the community of McKinley on the Parks Highway, is that the proximity of other buildings to the building you want to protect ranks even higher as a risk factor than the distance to the trees. And I would note here that by hosting this tool, this data on a REST services platform, Jen's been able to make it usable and downloadable by the agency partners. So here's a very clearly stated management question. When will a previous burn scar limit the next fire? And it depends, on weather, obviously, and time. But fire practitioners can immediately relate to and understand the value and importance of this. And this is Ben Gagliotti here. His work also seems to indicate that we may be beginning to see fuels feedbacks or a limiting effect on the fire extent in Alaska as fire becomes more extensive in the boreal. It's something that corroborates some modeling work that's been done previously by the Mac Lab and others, but his study uses observational data, and maybe it's a little good news for us in the boreal forest. He's working on the publication here, so watch for it. I think it's going to be pretty important. Now, here's a more complex issue example. Scott alluded to this, the carbon balance question. Managers have not been too sure what to think about carbon. Until very recently, it hasn't been considered to evaluate risk in their plans or directives. And this is starting to change as the carbon credits market expands and we learn more about the significance of boreal carbon stores to our planetary heat wave. But you can kind of read through this and see why it's hard for managers to digest all the different aspects of research that are coming out. So I'm going to kind of skip over the NASA part because Scott covered that so much, but I just wanted to mention that there's been a strong effort for stakeholder collaboration throughout the ABoVE project, not just beginning with phase 3, but beginning at the very beginning. And at the 9th science team meeting in January, we presented the summary and outcomes from a 2022 research operations workshop that we held in Fairbanks, and the website, Alaska Fire Science Consortium website, has about 15 recordings available from the presentations that were at that spring workshop, as well as links to our first workshop. There's too many products to list them all, and Scott gave you some examples already, but from a more manager's dashboard sort of point of view, here's a few examples of projects that I wanted to call out. One, like the use of NASA satellite snow off data for spring fire risk assessment that happened the first time in 2022. And the first statewide look at vegetation trends impacted by fire and climate change. There's a synthesis of agency and academic tundra fire plot data that's soon to be available on the DAC. A great collaboration. There's a preliminary tool to assess duff soil moisture using the SMAP data, and also testing and assessment in an operational space of new smoke models and tools to measure carbon combustion and emissions. That's just a really short list. So another one that we're really interested in pursuing hard, it would be a game changer for us, is improving the science of fire fuels mapping. These recent projects, including ABoVE, using big data from remote sensing and machine learning, have demonstrated the ability to make these fuels maps a lot better than the ones we're using. There's a product called Landfire that's a nationally produced interagency vegetation fuels map at a 30-meter resolution, and management agencies are required to use this in their wildfire decision-making algorithms and short-term fire behavior modeling. But it has flaws in latency, accuracy, and frankly, the methods are getting pretty old school. So a challenge is how to bring these, kind of research projects now into the public sphere and keep them updated. And this quote from John Wang, I think, summarizes it pretty well, and why it is an ongoing challenge. So here's just wrapping up here. Here's just a few examples of challenges to useful co-production. I already alluded to, the fact that different spatial fuels layers for vegetation, fire fuels layers are often used between managers and in the world of research for different reasons. There's always language disconnects, not just units, but also how we refer to things like fire weather indices, whereas if researchers will use, temperature and precipitation, and we have to get together on the same page to talk about, are we talking about vegetation? How do we translate that into fuel types that are used in fire behavior modeling? And then there's just cultural differences between these worlds, with management folks and practitioners very reliant on their experiential observations, whereas things that are produced in the world of research must be proven and backed with statistics. And finally, it seems like a call we've been seeing more recently from the managers is just like, wow, too much information. We need some synthesis here. We need to put these things together so that we can make sense of it, because there's just too much coming in from too many directions for us to make sense of. One way to synthesize information is put it in a picture. And I thought, here's a couple of great examples. The first one there is a picture that was put together by fire practitioners to explain how they think about the Alaska fire season and its drivers, used to communicate not only to themselves, but also to their research collaborators. And the bottom picture is an academic media product that boils down a very complex topic of fire and thermokarst effects into a visual story. I love it. So in our 10 plus years now, right, Alison, 12 years maybe, of operating as a boundary spanning organization in this space, this is just a list of some of the things that we continue to find are extremely important in science co-production. No substitute for face-to-face, and going to each other's meetings, and just, communication. It works. And so that's what we've got. And I guess we'll just take any questions that you might have.
Thanks so much, Randi. And I don't know if people have been taking a look at the chat, but I would encourage you to see that there are a lot of links that different participants have added to the chat. We've got participants that Alison has added some information about the Joint Fire Science Program, and you can get on the Alaska Fire Science Consortium mailing list. She's put links in for the references. Also, Scott mentioned that the Applied Earth Observations and Innovations Partnership has a workshop next week, and you can still join through, there's a virtual component to it as well, and you can still join and listen to hear about how the NASA and the Forest Service are kind of working together, and different products that they have available. So take a look at the chat. All right, any questions for Randi and Alison? You can go ahead and unmute and ask it, or you can put it in the chat. We can relay it.
I have a comment for Scott. Is that I love that caribou migration animation slide. I could watch that all day long. That is just so cool.
We have another version of that that shows all of the different types of animal movements. You can see birds and marine mammals and caribou, and that one's kind of overwhelming, I think, because it's just all happening all at once, and it's really hard to tease it apart. So I like the caribou one better, I think.
Yeah, I was tempted to show the other one, but yeah, it is kind of overwhelming. Yeah, that caribou one's really quite interesting because people always said, you know, the caribou are following the green wave like wildebeest do in East Africa or something. But in fact, they're ahead of the green wave, moving quickly. Yeah, it's really interesting.
I find that when people ask, yeah, surfing the green wave, I find that when people who are not as familiar with the Arctic ask me questions about the Arctic, they always ask about the wildlife and animal movement. So it's always really nice to be able to talk about some of those movement activities. It always seems to come up. All right, well, I'm not seeing questions directed at Randi or Alison. Is there?
Sorry, I wanted to say thank you both. I really enjoyed both presentations. And I want to say, Randi, thanks for laying out some of the needs from the management perspective. You talked about there's a lot of information coming in from different angles related to fire, and that a synthesis is needed. I'm wondering if you can elaborate a little bit more on what type of synthesis you would think would be helpful. Are there specific topics related to fire, or just a synthesis of the state of fire science in Alaska in general?
Good question. So, you know, I think probably there's a need for synthesis in most of those big topics. So, for example, the one about carbon balance, you know, a manager is sitting there trying to figure out, is it practical for me to put maybe more of my refuges or more of my land into a higher level protection status to actually save carbon? But think about how many factors would go into a decision like that. And they are struggling with, like, okay, you know, what's the trade-off down the road if we have, you know, we protect this and then fuels become more contiguous across the landscape and we have more burning later? I mean, there's so many things to factor in. So it's difficult. What we have directly had them ask us for has to do with these hot button issues. So they want a synthesis on field treatment effects. Field treatment effects, how long do they last? How long do they need before you maintain them? What are the ecological effects? What are the actual fire behavior trade-offs? Because we haven't been able to test or, you know, burn these things right next to homes, obviously, in developments that much. There's been a few cases, probably less than 10 altogether that I'm aware of in the Alaska region. So a lot relies on modeling. So synthesis, you know, in all levels, but everything from short-term issues like that to the big issues like carbon and thermal karst. Wow, thermal karst is, we didn't know much about the we didn't realize how important wildfire disturbance was in terms of thermokarst on the landscape, and we're just now only starting to be able to put this in perspective with some recent studies. So like, I love the one study by Yaping Chen, who showed us that in the Arctic tundra areas of Alaska, so including the north and the west tundra, Arctic tundra areas of Alaska, about 7% of the thermokarst they could detect on the landscape using remote sensing is attributable to fire. So 7%. So that gives us an idea. How important is it in the overall scheme of things compared to just background climate changing, compared to beavers, compared to everything else, right? These are the things we need to know to put it in perspective and use it for decisions. And so lots of good examples there.
Thank you. That was really helpful.
I think that was really helpful because this is something that we're thinking about with our team, and it keeps coming up, this idea of looking at, I think, kind of the interactions between fire and you know, other types of disturbance like permafrost too, and then vegetation and what's useful for managers, land managers. And so I think, I don't know, it's something that we've kind of been grappling with, and our presentation last month by Adriana Foster talked a little bit about kind of the multi-disturbance synthesis work that she had led, and thinking about what are the different disturbances that seem to have some of the greatest impacts. But there were a lot of disturbances in her list that we still knew very little about. And so I think kind of really understanding those pieces together, and then how land managers can relate to that is really useful. I really liked your slide, Randi, when you were talking about the sea balance issue and how there were so many different papers and they are all saying slightly different things. And so what does that mean for land managers, I think, is really important. All right, well, we have a little bit of time left as a team, and I wonder, let's see, Elizabeth, were you able to summarize a little bit about what we came up with last time from our Jamboard, or is there more we want to think about?
I think the biggest theme, I mean, you kind of already touched upon the themes that were coming out of it, is kind of focusing on the interaction between vegetation, permafrost, and fire dynamics. And I think Randi's presentation today was super helpful, helping us identify some of the management needs and some of the gaps that can help land managers. And it seems like a synthesis is very much needed. Let me pull up the Jamboard, see if I can open it. One minute.
I might be able, is it just the one from last time? I think I have that open too. Let me find that one.
Yeah, I think if we go to that third slide, that is a good summary. I think that's where most of the information is. I'm just not able to find it. I had it open earlier.
Yeah, I did too. I think it's closed itself. Let me get that back here. Tried something new with using Jamboard. I don't know, it's new for me, and found it to be moderately helpful last time. Here, I got it. Let me go ahead and
I was just gonna say, just got it, and I can share my screen if you'd like.
I can put it up.
Okay.
Let's see. Okay. This was kind of what we came up with last time as we all met together. And I think the colors are not really they're not really representing anything necessarily. But as a team, we're still thinking about where do we go from here, and what are some other topics that the terrestrial ecosystems group in our ARPIC is interested in thinking about, and maybe if we wanted to come up with some kind of synthesis product, is it a white paper or a manuscript that we work on as a team, or is it a tool that we develop? And so we were kind of thinking about who else could we talk to, or where else we might want to go. And so these were ideas that our team members came up with last time. And so if others have ideas as well, we can throw them in here. I don't know if other people still have an idea. We have some members from the permafrost team on here. I think I saw Christina Shadell and also John O'Donnell on the line. I don't know if from your permafrost team, if you have any perspectives on what you're most interested in working on or moving towards, and if this kind of idea of vegetation permafrost fire dynamics fits into what you're thinking about. I don't know if they're still online.
I'll take, looking through to see.
Yeah.
I do see.
Hey, this
hey,
is John.
John.
Hey, yeah, for the permafrost community of practice, we do have sort of plans for this year to have some seminars on ground ice content. And so we're going to be inviting experts from that community. And I think the eventual goal is to host a workshop. So have the seminars on ground ice lead up to a workshop where we work on some sort of synthesis product or mapping product that would then be a geospatial layer that could be used by in the community, like the terrestrial ecosystems.
That sounds really neat. And yeah, I think that a workshop sounds like a really nice idea to do with that. And then thinking about, is there a mapping product? And so if you'll remember, team, IARPIC has these different deliverables within the implementation plan. And so they're all focused on a specific activity or group of activities that are happening in the Arctic space. And so the one we have on that we're showing right now on the Jamboard is deliverable 2.3.6, and it's updating essential variable maps, permafrost, ground ice content, topography, bathymetry, vegetation. There are others that our team is focused on, but we ended up really putting all of our ideas onto this page of the Jamboard, and it's broader than just this one particular deliverable. I don't know if someone else started to maybe say something. Maybe not. Next month, we are going to join the permafrost team for our meeting. They have a meeting May 4th, I think. Let's see. Let me see if I can share that instead. I'm fancy enough to do that. I have to stop sharing and then reshare. Do you see this webinar announcement? I'm not sure if that is showing
I can see it. Yep,
yes.
It's coming up. Thank you. So
this is our next month. We plan on listening in to this. It's the Permafrost Discovery Gateway has a webinar, but we're planning on joining in and listening as well. Next Generation Plant Biomass Maps for the Arctic Tundra Biome by Logan Berner, and it's on May 4th. And let me see if I can send you all this link so you can join if you want. I'll stick it in the chat. There we go. It's down here. Here's Logan. Staring off into the distance, looking very, very much like a scientist there. All right. So that's what we're planning for next month. And initially we had scoped to maybe not have meetings in the summer, but I think we've changed our mind after our meeting last month. We heard from our community that we should continue to try to keep up the momentum and to keep thinking about how we move the team forward and what folks are interested in. So we'll plan to have some team meetings over the summer as well. And hopefully by the fall, we'll have some kind of idea of where we want to go to from here. So any other
Liz, I just mentioned
comments?
That Christina Shadow could probably report back on this, but week after next, the Permafrost Carbon Network is having a workshop here at NAU. And pretty sure Christina will be part of that. I'm almost certain. And I see Mike Laurenti's online. I think Mike's coming in for that. So maybe they can get a little report back from that workshop. I think it's really designed, or the hope is to see where the permafrost carbon network goes next. So probably quite relevant to some of what we're talking about.
I think that's a great idea to hear a report from them in one of our meetings. So we'll put that on our list too. I like that. All right. Well, thank you all. And we'll look forward to, we'll send out an email about our joining up with the permafrost team for the talk next month. And we want to thank our speakers again. Thank you, Scott and Alison and Randy, for joining us today and helping us to move our team forward. So thanks, everyone.
Thank you.
Thanks.
Thank you.
Thanks.